All right, in this video, I'm going to discuss how to conduct a linear regression in Excel and how to interpret the output that Excel gives you. All right, so I have data here from 10 cars. All right, and right now I'm looking at their price value, and I'm thinking to myself, how could I predict this price? Maybe using some of this other information. Okay, and for right now, I'm going to start with the year because I know that cars are very expensive if they're new, but they get cheaper as they get older. So I'm basically going to use the year to predict the price. All right, whatever you're trying to predict, this is going to be Y, and whatever you're using to predict that value is going to be X. All right, so Y depends on X, right? So that's a dependent variable, and then X is the independent variable, okay? All right, once you've thought that through, you're ready to go ahead and do your regression. So let's go to the data analysis tool pack. So it should be up here. You press on data, and then you should see it over here. Okay. If you're not seeing this over here, that means you need to get the data analysis tool pack, which I'll provide a link to that, how to get that in the description of this video. Okay. So you might have to scroll down, but eventually you'll see regression. So click on that and press OK. If you have anything in here already, just delete it. All right. Okay, let's talk about this. So the Y range. All right. So the Y range is going to be the price. So I'm going to click on price, hold, drag it down until I get down to the bottom, and then release the click. Okay, so you see it says E1 basically to E11. Good, that's where it's located. Here's E1 all the way to E11. Next, the X range. Make sure you put your clicker, so click on the next one, okay? So you see my clicker is up here now. You need to make sure you move it down here by clicking it there. Okay, click on year, hold your clicker, and then release. Okay, so you see I have B1 to B11. Good. All right, I'm going to have the labels. The labels basically means that when I highlighted my data, I included the label. So I started at B1. I didn't start at B2. Okay, so my labels were included, so I need to make sure I press this labels. Okay, I included price when I highlighted my data. All right, constant equals 0. That's basically making the fit of the line go through the origin. We're not going to do that. We're also not going to calculate confidence level right now. All right. In terms of your output options, you have 3 output options. Output range will, if you put your clicker there and then click somewhere like here, it'll put the output there. I don't particularly like that. I mean, you can do that and it'll just put the output directly under below it. A lot of times I'll go ahead and say, go ahead and create a new worksheet, and it'll create a new worksheet down here. Okay, a new workbook means it's going to open up a whole nother Excel file and do that for you. Okay, residual, standardized residuals, residual plots, and fit line plots. Right now, I want you guys to click the residual and the line fit plots. Okay, these are very helpful in discussing your interpretations of your results. All right, boldly go ahead and leave these unclicked for right now, and we'll leave that unclicked. Okay, press OK. All right, let's see what we got here. So I'm going to double click to make this bigger so I can see what I have. All right, starting with the R squared value. All right, R squared gives us the percentage of the variability in price that's explained by this model. So in this case, explained by year. Okay, so 72% of the variability in price is explained by the year. That's pretty good, right? So a perfect linear relationship would have an R squared of 100. The worst linear relationship that you've ever seen in your life would have an R squared of 0. Okay, so 72 is a pretty strong linear relationship between year and price. Okay, multiple R is basically the correlation between price and year. Okay, R squared, it's just the squared of the multiple. Okay, so I could even type in here equals, click on this one, make it squared by using the little caret and then a 2. And you see that's all it is. Okay, so multiple square is just the correlation, and then r squared is basically the correlation squared. Okay, but this guy, he's a really important guy to understand. So it's the percentage of the variability of your dependent variable that's explained by your independent variables or variable. Okay, next, let's look at this next chart down here. This number right here, this is really important. This is saying whether or not your regression is significant. So did your regression do a good job of explaining the price variability? Okay, and if that p-value, a lot of times if the p-value, so that's basically what this is a p-value. If the p-value is less than 0.05, that is an indicator of significance. Okay, so 0.05, you can change that. That's like alpha or type 1 error, but 0.05 is a pretty normal standard alpha level or type 1 error level. So yeah, we'll go with that. That basically this significance, this is a significant regression. Okay, so once again, year did a pretty good job of explaining price. Okay, moving down to the next part of this chart here. I want us to pay attention to these two numbers. Okay, and these two numbers. Okay, well actually a little less that one and a little more that one. Okay, so the coefficients, right? Starting with the coefficients. Y equals beta 0 plus beta 1 x. Okay, this is a linear regression, right? And I can have y hat, right? And that means the predicted value of y hat. So the predicted price value is y hat. All right, and what is, well, and then I would also need hats over these guys too. This is the predicted intercept and the predicted slope. Okay, so remember y equals mx plus b from like high school when you were learning about a linear line? That's basically the same thing. So this b here is the intercept, m is the slope. Okay, all right. Now we can get these values, so y hat, b naught, right? This is the intercept, so it's at negative 3,669,268.926, okay? Plus 1830.06, some more decimals there, times x basically. All right, so if you give me a year, an x value, remember x is the year. If you give me a year, I can predict a price for you using this equation. All right, so let's talk about that. So like say for example, I had the year, a predicted year was 2021. Okay, so next year, let's predict a price of a vehicle next year. So y hat, the predicted value, okay, equals, instead of typing this all out and risking potentially mistyping it, I'm just going to click on that coefficient, plus, click on that coefficient, times 2021. Okay, so this is the y hat value at 2021. Press enter, and let me go home and make that into a dollar sign. So next year, these cars, I'm expecting it to cost me $29,288. Okay. What about if I wanted to predict what it costs in 2000? All right. So y hat in 2000 equals the intercept plus the year times 2000. All right, and we see here this is a negative number. All right, now can cars cost something that's a negative amount? Well, I guess someone can give you money for taking that car off their hands, because 2000 car is quite old, right? But really, I mean, it doesn't make a lot of sense for a price to be negative. Okay, and that's what's going on here is you're basically going beyond the range of your data. In my original data, I didn't have a car from 2000. Okay, so when you go beyond the range of your data, the prediction gets worse and worse. Okay, and that's basically what you're seeing happen here. Remember, this is a linear line, so eventually it's going to go negative. All right, and then also eventually it's going to probably go way too high. All right, prices don't just linearly decrease forever, and they don't linearly increase forever. All right, but in this area where my data is, the linear regression is doing pretty good. Okay, I'm going to talk more about this plot here in a second. But before I move on to that plot, let's talk about this p-value. This p-value, 0.001, right, that's less than 0.05. So that is significant. So that's basically saying year is a significant predictor of price. Okay? All right. All right, so now let's talk for a moment about this plot. All right, so these dots here, these are the predicted price values, and you see the linear line that they're lining up in. That is basically this equation. That is this equation. They've plotted it out for you. All right. All right, the blue dots are what we actually, from our data, these are our 10 observations, these little blue dots. All right, so you can see how close the prediction is to our real data. All right, and sometimes it's really close, and then sometimes you do see it slightly further away. All right. Okay, and that brings me lastly to this right here. This chart right here is going to tell you the predicted price and the residual price for every observation. So the order of the observations is the same as the order of your observations here. Okay, so this is the first observation, costing $23,500. The predicted value, right, which is this equation here. When you use this equation, you get $21,968 or $69 if you round it, which the residual is basically how far off that predicted value is from your observed value. Okay, so let me show you what I just said. So basically, so what year was that? That was a 2017 car costing $23,550 or $23,500. 2017 car, the real Y was $23,500. So this is the Y observed. Okay, 2017 Y hat, or the Y predicted value, would be, we would start with our intercept plus the year, the coefficient for the year, times 2017. Press enter, and you see we're getting that same predicted value that they had. Okay, the residual is the difference between the observed and the predicted. Okay, and so you see that there. All right, so how far off from the observed value is your predicted value? All right. Okay, now moving on. What if I want to possibly look into more than just year predicting price? Maybe the miles per gallon also predicts price. So now I'm going to have like the first variable and a second variable. All right, so it's more than just one X now. Okay, to do this in Excel, the first thing I need to do is actually move this column next to this column. Excel likes all of your X's to be right next to each other. Okay, so to do that, I'm going to press on B. I'm going to right click and press, let's see, cut. All right. Then I'm going to press on F, and I'm going to press insert cut cells. All right, there we go. So this is, let's see, X1 and X2, and it needs to be in this order in order for your results to also be in that order. Okay. All right. So let's see. Let's go to data analysis. Press on regression. Press OK. If you already have things in there, go ahead and delete them. Okay. All right. Then make sure your cursor is in the Y range and highlight price. Drag it down. Let go. Okay. So D1 to D11. Good. X range. So hold year. Go over to miles per gallon. Then go down. Release. Okay. I still have the labels. I included the labels when I highlighted it. I still want to do a new worksheet, and I want to include the residuals in the line fit plots. Press OK. Okay. So now I have 2 plots here. Okay. So let's see what we have here. Okay. So starting with our R squared, we still have a very good R squared. This is saying that 72, or 73 if I round that, 73% of the variability in price is explained by year and miles per gallon. Okay. So let's see, did it go up from what it was before? Slightly. It used to be 72, and now if you round that, it's 73. Which makes sense because we gave it another variable to help it predict the price. Okay. Next, the significance of the model. Does this model do a good job of predicting price? And it does, right? This is still less than 0.05, right? And remember, a lot of times we go ahead and we'll use 0.05 as our acceptable type 1 error. Okay. All right. If you had 0.01, which some people will sometimes use alpha equal 0.01, this is not less than 0.01, so this model would not be significant. Okay, so it does matter what alpha you choose, which a lot of times that depends on what field you're in. Okay, so like a lot of the biological sciences will use smaller p-values than, say, the social sciences. Okay, so that's kind of a field dependent what alpha they feel comfortable with. All right, moving on to our model down here. These coefficients are really important. Let's look at those. Also, these p-values are really important, so let's consider those. Starting with the coefficients, all right, let's write down our model. Let me write down our model here. So we have y equal, always start with your intercept, negative 34352.904. That's the intercept. Okay, plus, all right, so it goes beta 0 plus beta 1 x1 plus beta 2 x2. Okay, so beta are these coefficients. So 17, 11.4, I'm going to round that, times year. Okay, so instead of writing x1, I'm going to write year. You could also write x1, doesn't matter, same thing. Plus 197 point, let's see, if you round that, 0.4 times miles per gallon. Okay, or you could write x2, same thing. Okay, so that's our model. And we can use that model if you give me a year, so like say 2017, and then a certain miles per gallon, say 25 miles per gallon, then I can make a prediction. So a y hat, given those two pieces of information, I would have this coefficient plus the next coefficient times whatever year I have, so 2017, plus miles per gallon times whatever miles per gallon I have, which is 25. Okay, and then I can predict the price of the car is going to be $21,632.92. Okay, all right, next moving on to these p-values. What do these p-values mean? Well, that first p-value is less than 0.05, so it's a significant p-value. It's a significant predictor, basically. Year is a significant predictor because that p-value is less than 0.05. Okay, so that's a significant predictor. It's an important predictor at predicting price. Next, we have miles per gallon, p-value. Is that less than 0.05? No, it is not, right? That is not less than 0.05. So because that is not less than 0.05, miles per gallon is actually not an important or significant predictor of price. Okay, and we can kind of see that when we look at these charts. So you see here, the yellow, remember, or the orange is our predicted price value, and then the blue is what is actually observed. And we see a nice kind of linear relationship when you plot year and price together. However, when you plot miles per gallon and price together, you kind of see a mess, right? It doesn't really look that linear. And since you're not seeing that nice linear shape in this scatter plot, that's an indicator that miles per gallon is not doing a great job of predicting price. They're not linearly related to each other. All right? Okay. And once again, we still have our predicted values and the residuals given to us in this last chart here for each observation that we had.